Today we're going to learn how to take x-intercepts, y-intercepts, max or mins, other information about the parabolas, and we're going to learn how to write an equation for the parabola. Okay, does anybody remember our factored form for the equation? Does anybody remember what that was? The factored form?
A comma x minus m.
Y equals a times
X minus n.
okay,
Or n.
then x minus
N.
n. So that's our factored form, right? That's going to be our basis for writing our equations. Right? What is m and n?
The x-intercept.
X. Oh, we got a couple things here.
X-intercept.
They're the x-intercepts. What do you think it was, Trey? Nope, they're not that. They're the intercepts. Okay. If it's a parabola, it can only have one min or max. It can't have both. Okay. So m and n are x-intercepts. A determines what?
If it opens up or down.
Good. If it opens up or down. A tells us if the parabola opens up, opens down. When A is positive, it opens up. When A is negative, it opens down. Okay. So what we're going to do is we will learn how to write equations for parabolas when we are given the x-intercepts and other information. So for the first one, my x-intercepts are -2, 0, and 8, 0. Right? -2, 0, and 8, 0. What does that tell me about the equation? Brock, what do you think it tells me?
That.
All right, anyone want to help out Rock? Mark? Okay, they're points on a parabola, but they're special points, right? There are x-intercepts. So what does that tell me for my equation?
You can plug the x-intercepts for m and n.
Good. The x-intercepts get plugged in for m and n, right? So if my x-intercept is -2, that means m is what? -2. If x-intercept is 8, 0, that means n is
Or 8.
8. Right? Does that make sense? So yesterday we started with the equation and we worked to these. Now we're starting with these and we're going to fill them into the equation.
So they just give us it?
Yep, they just tell you what the x-intercepts are, and we're trying to write the equation.
What's going to be the m and the n every time?
X-intercepts are always the m and the n, yep. Okay. Now, this one opens up. That's the only information it gives me, is that it opens up, besides the x-intercepts. So if it opens up, what does that mean for our A?
It's positive.
Positive. So since it opens up, that means we have a positive A value. And we'll find the what, Austin? It'll have a minimum because it opens up. All right, so it's a positive A value. So that's all I know about A is it's going to be a positive value. So A can be any positive number then. Right? I don't care what you write as long as A is a positive number. Right? So I can use this information and I can fill in my equation. Right? So we're going to have y equals, then A can be any positive number. So what do you want it to be?
1.
1, okay, I like 1. 2 is fine. Okay. So 1, then we have x minus -2, x minus 8. Because -2 was my m, and 8 was my n. Right? Does that make sense? Yeah. Now, what's minus negative do? Change it to a positive. So y equals 1 times x plus 2 times x minus 8. So it looks like that. Okay. Now, how can I check to make sure that this equation represents that information?
Plug in 0 for x.
Plug it into what?
0 for x.
Nope, don't plug 0 for x. We go to our calculator and write this equation in our y equals. Shouldn't we get a parabola that opens up and crosses the x-axis at -2 and 8? Yeah, so let's try that out. So take your calculators, go to the y equals page, or the y equals screen, and plug in that equation. Yes. Yeah. Which one's yours? Here we go, right here. There isn't a 19?
Right here.
Oh, so I'm thinking 19. Huh?
You just said that on recording. Tony.
Yeah, you got a calculator?
No, I got mine.
Say, please. Say that I have it.
Josh.
Oh, was it recording?
Yeah, you know how it goes.
I didn't know.
Okay. So when we plug it in, what does it look like? It opened up. Did it cross at? Did it cross at -2 and 8? Yeah, it looks like it. Okay. So that's a way we can quickly check. That's a way we can quickly check to see if our equation's right. All right. Now, if you look at your graph and it doesn't look right, or the window's too small or too big, you get zoom 6, then it'll make a better window so you can see it. All right. Now, once again, since it says it opens up, we could use any A. We can use any A value as long as it's positive. All right. Any questions? All right. What's the question, David? Yeah.
A good pencil. Got a good eraser.
All right. Next one, example 2. We have x-intercepts of 3, 0 and 9, 0. And this time, instead of just saying it opens up, they give us a maximum. Okay? So, if it has x-intercept of 3 and 9, what are my m and my n's?
The m is 3 and the n is 9.
Good. M is 3 and n is 9. Right? Does that make sense?
Yes.
Okay. Since we have a maximum, what does that mean?
It opens down.
It opens down and A is negative. Got my A's. A is negative, right? It opens down, we have a negative A. Okay, so we can get started with our equation, right? So we're going to have y equals A times x. What do I do now? What goes next? Minus 3, because 3 is my m. Then x minus 9. So there's our equation, right? Now, this example is a little more specific than example 1. Example 1, they just said it opens up. So A could be any number, right? This one, they give us a maximum. How many A values will give us that maximum? 1. There's only one A value that will give us that maximum. So guess what? We got to find that A value. Okay? So we have to find A by doing what? Nope, not using our calculator. By plugging in. What's my x value for my max? What's my x value for my max? 6. By plugging in 6 for x and 18 for y and solving for what?
A.
Solving for A. So since this one's more specific, they actually give me a point for our maximum, we have to actually find the A. We can't just say it's any positive number, then pick our positive number. Mark, you got a question? You know what? Okay. So let's all catch up then. All right? All right, we'll get there in a second, okay? All right. So I'll plug in 18 for y and 6 for x. So we'll get this. 18 equals A times 6 minus 3 times 6 minus 9. So look like that. 18 equals A times 6 minus 3 times 6 minus 9. Does that make sense? Plug in 6 for x, 18 for y. Okay, you guys? Okay. What's 6 minus 3? 3. What's 6 minus 9? Negative 3. So then I'm going to have 18 equals A times 3 times negative 3. What's negative 3 times 3? Negative 9. So we're going to have 18 equals A times negative 9. What do I do now? Okay. We want to solve for A, so we got to do the opposite of this, right? So we got to divide it. So an 18 divided by negative 9 is? So now is that it? Is that the answer? Just a equals -2? No. I wanted you to write an equation, didn't I? Okay. So our equation then, with a being -2, is y equals -2 times x
minus 3.
minus 3
X minus 9.
x minus 9. Austin, you get a drink? No? Okay. So y equals -2 times x minus 3 times x minus 9. Now we could use our calculator again to check ourselves, couldn't we? We could, right? But this one, they gave me 3 points now, don't they? So do I need my calculator to check myself? No, I can make the graph myself, couldn't I? So I'm going to make a quick graph. All right, we'll do it right here. Oops, that's a little too high. Okay, we know it crosses at 3090, right? So that could be 3. That could be 9, right? 6 is going to be halfway in between those. That's going to go up to 618. So my graph, oops, just missed my 9. My graph would look like that. Right? Is that what we expected? Having a maximum that's going to open down, x-intercept 3090. Now, if you looked on your calculator, it would look something like that, right? Except with your window on your calculator, it only goes up to 10 for the y. So you have to go to your window and change your y max to 20. Then you get a better picture of it. So your window and change your y max to 20, then you'll get a better picture. And it should look like that. All right. Are there any questions about this example? Any questions about this example? No? Okay. Our last example then, example 3. How many x-intercepts are there? 1. What are they? They're both what? The x-intercept is what? -5. So if I have 1 x-intercept, Jay, then what's my m value?
0. 1.
Okay. Remember, our m's are x-intercepts, right? So my m is going to be -5. What's my n going to be?
1.
Nope. I have 1 x-intercept, so that means my n is also going to be -5. Okay? If you have 1 x-intercept, that means your m and your n are both the same. Okay? That's because, Matt, this graph looks like this. It comes down and it just bumps into the axis at, oops, it should be -5. But it just bumps into the axis just once. Okay? That's why our m and our n's are the same. Right? So to get my equation started, we're going to have y equals a times x minus -5 and x minus -5. Right? What do 2 minuses make it? Plus. So it's going to be y equals a times x plus 5 times x plus 5. Now, they give me a third point, don't they? So they give me the y-intercept. Can I use this to find my a?
You plug in 10 for y.
10 goes in for y, and what goes in for x? 0. So let me plug in 10 for y and 0 for x. Now to find our a, what do we use now?
Algebra.
Algebra. Good. 0 plus 5 is 5. So both of these are 5. Now a common mistake that students will make. These 5s are next to each other. What do you think students try to do? They add them. Is there a plus in there? No. When I have 2 parentheses next to each other, what does that mean? Times a multiply, right? So 5 times 5 is 25. 25. Okay. So we got 10 equals a times 25. So what do I do now? No, other way.
Divide.
It's a times 25, so we divide by 25.
0.4.
Oh, someone said 10 or 25 divided by 10. So 10 divided by 25 is what?
0.4.
0.4. So 0.4 equals a, and that means our equation then is y equals
0.4 x plus 5 x plus 5.
But when I have x plus 5 repeated, what can I do with it?
You can put a square.
You can put a square, right? So when I have x plus 5 repeated, I can write it like this. Y equals 0.4 times x plus 5 squared. And that's my answer. And once again, you can graph that on your calculator. You can graph that on your calculator to check, see what's right as well. All right? Are there any questions? Any questions?